Hey grade 12s and happy new year. Hope you guys are doing well and are getting settled in for the 2026 academic year. In this video, we're going to be working on the grade 12 mathematics March test for 2025. Now, you will probably notice this says marking guidelines because I can't actually find the test itself. I found images of it, okay, of all the 5 questions, but not the actual test. So you're still going to see the normal questions, okay, because I found the images of it. And that's what we're going to work with here. And I'm posting it now so you can use it in preparation for your March tests in 2026, okay, and any other year really. So with that being said, let's get into this video. Question 1, 1.1.1 says we need to solve for x and we're given this equation. So they've already been factorized and one hand side is equal to 0. So we can just equate each bracket to 0. So x minus 9 equals 0. Therefore, x is equal to positive 9. And this is 1 plus 2x, which is the same as 2x plus 1. Okay, if you equate it to 0, we're just saying 2x is equal to negative 1. Okay, so we can just say or 2x equals negative 1 and divide both hand sides by 2. Therefore, x is equal to negative 1 over 2. And those are our answers. Moving on to the next question. Question 1.1.2 says we have to solve for x correct to 2 decimal places, meaning our solutions are irrational. Now, it's already put in the standard form of a quadratic equation, so we can use the quadratic formula to solve for x. Okay, so here's the quadratic formula, and it's in the form of ax squared plus bx plus c is equal to 0. So from this, we can see that the value of b, we have negative, and b is 1, that coefficient of x, okay? The number in front of x is 1, plus minus the square root of, that's just going to be 1 squared, minus 4 multiplied by a, which is 1, times c, which is negative 13. And let's go ahead. Okay, so all over 2a. So 2 times 1. And let's find our values. So x is equal to 2 values, and we'll start with a positive. And x is equal to 3.14, rounded off to 2 decimal places. And if you change that to a minus, x is equal to negative 4.14. And those are our solutions. Moving on to the next question. Question 1.1.3 says we have this equation, this exponential equation, and we need to solve for x. Okay, so do you see repetition? We have 3 to the power of x here and 3 to the power of x here. Why don't we just bring this over? So we have 2 multiplied by 3 to the power of x, and this now becomes plus 3 to the power of x is equal to 81. And now we can take 3 to the power of x out as a common factor. And so what is left in the first term? We just say this divided by that common factor, it will just give us 2. And then the second term divided by the common factor, we just have positive 1 because they're the same thing, is equal to 81. And you see this adds up to 3. So 3 to the power of x times 3 is equal to 81. And at this point, you can just divide both sides by 3. That's fine. And so this is now equal to, we'll just continue here. So we have 3 to the power of x is therefore equal to 81 divided by 3 is 27. And now we can rewrite 27 as a base of 3. So that's 3 to the power of 3. Therefore, x is equal to 3. And that is our answer. Moving on to the next question. Next, we have an inequality. Okay, so they've already factorized this for us. And so we can just find the critical values. But before finding the critical values, look at what would happen if we had to distribute, right? If you multiply the x with the 4, of course, you get the 4x. But if you multiply x with negative x, that gives us negative x squared. So this will be a quadratic equation or quadratic expression with the coefficient of x squared being negative, meaning it will form a concave down parabola. Okay, we'll just keep that in mind. So let's find our critical values. And we find those simply by setting these equal to 0. So here, x is simply equal to negative 1. And here, if you set 4 minus x is equal to 0, and you transpose the x, you see that it just becomes positive, so x is equal to 4. Okay, so these are our critical values, and we know it forms a concave down parabola. If we look at it like this, and we're just going to have -1 and 4. Now, it could form a concave up parabola just depending on how you distribute and factorize it. But I'm not going to do that. I'm just going to stick to finding the critical values and seeing it as a concave down parabola. The solution, however, will still be exactly the same. So this wants us to solve for x, or find the values of x, for which this expression will have positive values, values greater than 0. So on the graph, this refers to the y values. The y values greater than 0 lie here. Okay, these are all positive y values that we find up here, and less than 0 is here. So we need to focus on these. The parts of the graph that have positive y values, you will see that these are all the parts of the graph that lie above the x-axis. Okay, so that's all through here. Everything here has positive y values as long as it's above the x-axis. So if you line this down now to the x-axis, you see that these are values that are to the right of -1 and to the left of 4. So these are values that are greater than -1 but less than 4. And that is our answer. We'll simply say, therefore, this means x is greater than -1 but less than 4. Not equal to, because they don't say greater or equal to. Okay, so that is our answer. Moving on to the next question. Question 1.1.5, we are given an equation with a surd. So with equations with surds, you first have to isolate the surd so that you can, get rid of that surd. But it's already isolated, which makes sense. That's why it's for 4 marks. And so we can get rid of the surd now by squaring both hand sides, because that's what will get rid of a square root. So that breaks open the square root, and now we have here x minus 2 is equal to, and now this is squared, so we have a binomial squared. So you can write this as 4 minus x multiplied by 4 minus x, but that takes a while. So you can also simplify it quickly like this. We first square the first term, which is 4 squared, which is 16. And then the last term, negative x all squared, is positive x squared. And then say first term times second term. That will give us negative 4x. And then you multiply that by 2. So that's negative 8x. And now you see that x squared is positive on this side, so we can just go ahead and take everything over to the right-hand side. So 0 is equal to, and we have x squared minus 8x, and this comes over and becomes minus x, so we have negative 9x. And then positive 16, and this comes over and becomes a positive 2, so we have positive 18, okay, is equal to 0. And now we can go ahead and factorize. So open up 2 brackets, equate it to 0, x multiplied by x is x squared, and then factors of 18 that can give us 9. We can say negative 3 and negative 6. Notice they're both negative because negative 3 times negative 6 give us positive 18, but negative 3 minus 6 give us negative 9. And so x is either equal to 3 or x is equal to 6. But here's the thing, you need to check whether these solutions are valid or not. Do you see that in our initial equation, the highest exponent on x was 1, meaning there was one possible solution. And then we deliberately squared both hand side. This can tamper with the solution. So now we need to check if our solutions are valid. So just take it from a point before you had squared both hand side. You can't take it from here, okay? You have to take it from the point where we had a surd. So when we had the square root of x minus 2, and then is equal to 4 minus x. So we'll just take the original. And we need to ensure that the left-hand side is equal to the right-hand side for this particular value of x. Okay, so when we substitute x equals to 3. So if this is 3 and this is 3, let's see if the left-hand side is equal to the right-hand side. 3 minus 2 is 1. Square root of 1 is 1. 4 minus 3 is 1. Great, so this actually works out. Let's check 6. If we substitute 6 here and 6 here, 6 minus 2 is 4. Square root of 4 is 2. 4 minus 6, however, is negative 2. So you see how these are not the same number. Therefore, x is not equal to 6. And you need to show that you have cancelled that. So that answer is invalid, meaning x is equal to 3 only. And that is it for this question. Moving on to the next question. Question 1.2, let's say 12, okay. Okay, so it's supposed to be 1.2. We have a simultaneous equation. In simultaneous equations, spot the linear equation or the equation that can be made linear. For example, like an exponential equation. Okay, you can get a linear equation from that, or even a logarithmic equation. Any equation with log, because it can be, expressed as an exponential and so on. That's just a tip for any future exams. Okay, so for example, if we have a simple equation like 5 to the power of x is equal to 5, yeah, sure, it's exponential, but you see that because the bases are the same, we can just equate the exponents, and there you have a linear equation. Okay, so that's something that you should also just keep in mind. But with this one, we can see this is the linear. This is the one with, squares and stuff on the x and y. So we're going to take this further. The y is on its own, but it's negative. Okay, it's alone, but we can just transpose it to make it positive. So it's now positive y, and then we have the 2x, and we'll transpose the 5 to get negative 5. So we're just saying y equals 2x minus 5, and we can go ahead and call this equation 1. And then this is still equation 2. So to solve for x, we'll say sub equation 1 into equation 2. And now we're going to say wherever we see y, we replace it with 2x minus 5. So this is x squared minus, and there's y squared. So we'll say 2x minus 5 all squared is equal to 7. Okay, so this is x squared, this is minus, and let's distribute. First term squared is 4x squared. Last term squared is positive 25. First term times second term is negative 10x. Times 2 is negative 20x. So minus 7 is equal to 0. And now we have x squared, and we distribute the negative in. It's going to be negative 4x squared, and then positive 20x, and negative 25, and minus 7 is equal to 0. So therefore, we have negative 3x squared plus 20x, and that will give us, so that's negative 32. So negative 32 is equal to 0. But as you can see, there's a negative all through because this is negative. It should be positive, so we can factorize it. So you can multiply or divide both hand sides by negative 1. And so our equation is now positive 3x squared minus 20x, and then positive 32 is equal to 0. And we need to factorize this. Okay, factors of 3x squared. 3x multiplied by x give us 3x squared. And then factors of 32, we need factors that can help us get 20. Okay, let's see. 32. Well, I'm just going to say shift fact so I can just look at their factors. It's factors. It's 2 all the way, like 2 times 2, 5 times basically. And let's see how we can do that. You can say 2 to the power of 3 times 2 to the power of 2. So that's 8 times 4. Can that help to give 20? Another thing we need to take note of is only the middle is negative, and this is positive. So you can only say a negative multiplied by a negative to get that positive, but maintain a negative in the middle. So these two are also going to be negative. Okay, so if I put the 4 here, I'm going to get 12 when I multiply across. And if I put the 8 here, okay, yeah, this could work. So we're going to have 3x times, this one was just a guess, okay? Sometimes you have to guess, sometimes you have to actually think about it properly. So 3x times negative 4 is negative 12x, and then x times negative 8 is negative 8x, and then we know that together they give us negative 20x. So this worked out perfectly. Great. And so our factors are 3x minus 8 and x minus 4 is equal to 0. Therefore, 3x is equal to 8. Divide both sides by 3. Therefore, x is equal to 8 over 3. Or x is equal to positive 4. Okay, so we've got our solutions for x, and now we can use that to find our solutions for y. So y equals 2x minus 5. Okay, so we'll say y equals 2x minus 5, or y equals, and we'll substitute that x value, and minus 5. So 8 over 3, and this is 4. So this is just 16 over 3, and 5 can be expressed as 15 over 3. So that is 1 over 3. Okay, y here is equal to 1 over 3. And here, that's 8 minus 5, which is 3. Okay, y is equal to 3. So our solutions are x is equal to 8 over 3, while y equals 1 over 3, or x is equal to 4 while y is equal to 3. And that is our answer, and that is it for question 1. Question 2.1 says, given the geometric series 8x squared minus 4x cubed plus 2x to the power of 4, and this keeps going, we have to determine for which values of x will the series converge. Okay, so a series will converge if the ratio is greater than -1 but less than 1. So you'll see that as you find the value of each term, they'll get closer and closer to 0. Okay, so here's another thing that you'll notice about these geometric series. Okay, so they're in the form of, or really if you represent it as a graph, you're going to get an exponential function. Okay, now remember that it's in the form of, right, the term values are in the form of a multiplied by r raised to the power of n minus 1. Okay, now think about what an exponential function's equation looks like. That is y equals a times a base raised to the power of x minus p plus q. Now, do you see here that we do not have any plus q? This means that the value of q here, your horizontal asymptote, is 0. Okay, so you have a graph that has a horizontal asymptote of y equals 0. And what this graph is doing is that its values, okay, its term values, are getting smaller and smaller and smaller, and they're getting closer and closer to this x-axis, okay, where y is equal to 0. But they will never touch the x-axis. And that's why they run infinitely closer to that x-axis, okay, or that line y equals 0. So they converge. Okay, so that's another way to see that. Of course, this is a decreasing function. So this is what we have, and we just need to ensure that r is greater than -1 but less than 1. But with that, you need to take this constraint into account. You see, r can't be equal to 0. If you have r equal to 0, that won't even be a geometric pattern, okay? It's just going to be 0 and 0 and more zeros, okay? Because it's just going to multiply every time by 0. So we need to keep that in mind. Okay, so the first goal here is find out what r is. So to find r, you can say term 2 divided by term 1, or term 3 divided by term 2. So if we say term 2, which is -4x cubed, divided by term 1, 8x squared, what do we get? So r is equal to, this is -1 over 2x, okay? And so we need to ensure that our ratio, -1 over 2x, is greater than -1 but less than 1, but not equal to 0. So ensure that -1 over 2x is not equal to 0, and then it will converge. Okay, so this is what we have, and I can just solve for x here just because x is actually going to have one of those values, and we need to ensure that it's not equal to 0. So if you divide both hand sides by -1/2, you just get that x should not be equal to 0. We'll keep that in mind. And now to solve for this inequality, you see that we just have -1 over 2x. You can simply divide all sides by -1 over 2, or you can see this as multiplying all sides by -2. And that will help to get rid of that -1 over 2. Okay, so this is going to become x, and this will become +2. This will become -2, but we multiply by a negative value. So it will cause the signs to change. So now the signs change direction. That's not a problem. It looks awkward right now, but you can just rewrite it properly. The lesser value needs to be here. So it's -2 over here. The higher value is here. And so it still follows the way this inequality looks. X versus -2, do you see that the inequality faces the x? So draw it facing the x. And again, same thing over here, x versus 2, draw it facing the 2. So we're still saying x needs to be greater than -2, but less than 2, but x must not be equal to 0. And that is our answer. Moving on to the next question. Question 2.1.2 says, determine the sum to infinity if x is equal to 3 over 2. So to determine the sum to infinity, we know that the equation is a over 1 minus r. So we need the value of a and r. We know that a, the first term in the series, is 8x squared. So to find a, we'll say a is equal to 8x squared. And in place of x, we substitute 3 over 2. So this is 3 over 2 all squared. And you can just find this value. It's fine on the calculator. And that is 18. And then we just need the value of r, which is negative 1 over 2x. So r equals negative 1 over 2x, but we know that x is 3 over 2. So this is just negative 3 over 4. So r equals negative 3 over 4. And now we can go ahead and find the sum to infinity. So the sum to infinity, looking at the value of a and r, we know that the sum to infinity is equal to 18 over 1 minus negative 3 over 4, which it's fine. You can also just put this on the calculator, and here's our answer. Okay, which is equal to 72 over 7, and you can simplify this as, well, I like to leave it as a fraction. So that is our answer. I just want to get the sum of all of that. And that is our answer. Moving on to the next question. Question 2.2 says, the second term of a quadratic number pattern is 13. Okay, second term of a quadratic number pattern is 13. The general term of the first difference of the quadratic number pattern is given by this. So this is a different pattern. So this is the first differences, okay, which is a linear pattern, and this is its formula. And 2.2.1 says, determine the first 5 terms of the quadratic number pattern. So first 5 terms of the quadratic number pattern in this. Okay, let's write down what we have. We were given the second term of the quadratic pattern. Okay, term 2 is 13. We were also given the equation of the first differences. So it means we have a term 1, right? We'll have to find out that. And we were given the equation of the first differences. So we can find any term in the first differences. But we need to ensure that we have the first 5 terms. So we need term 3, term 4, and term 5. So what in the first differences do you need to find the rest of the terms? We're going to need the first term in the first differences. And you see, with the first differences, it also tells you the constant difference, okay? It tells you what that second constant difference is. So yes, this is enough to find it. So we're going to use it to find the third term and then the fourth term. Let's go ahead and find this first term in the first differences. If we know that the formula is Tn equals 8n plus 2, the first term in the first differences will be found by saying 8 times 1 plus 2, which is 10. Okay, so that's term 1. It's equal to 10. So if this is 10, what is this term? Well, we would say term 1 plus this term, the first term in the first difference, to get 13. So what plus 10 gives you 13? That is 3. So we now know that the first term in the quadratic pattern is 3. How do we find the rest? Okay, you can't just, there's really 2 ways of doing this. I just want to deal with this the simple way. Okay, you could go ahead and find that second constant difference, which is really unnecessary. So I don't want to do that. And what I'm just going to do is focus on finding these other 3 terms in the first difference. So let's find term 2. Term 2 in the first difference is 8 times 2 plus 2. So this is 16 plus 2, which is 18. And so we know now this is 18. 13 plus 18 is 31. Okay, so we have 31 over there. That's the third term. And we're just doing this to find the remaining terms. So find term 3 and term 4 in the first differences. So this is 8 times 3 plus 2. 8 times 3 is 24 plus 2 is 26. So 26 plus, if this is 26, then that is going to be 57. And then lastly, we have term 4, which is 8 times 4 plus 2. And then that is 16 plus 16 is 32. So that is 32 plus 2, which is 34. Okay, so this is 34. And then so 57 plus 34, that is going to be 8, 11, so 91. And that is our answer. The first 5 terms are 3, 13, 31, 57, and 91. And that is our answer. Moving on to the next question. Question 2.2.2 says, hence determine the general term. And it's the general term of that quadratic pattern. Okay, so we have the first term in the quadratic pattern, the first term in the second difference, and we can see that the second constant difference, we can see it from here, it's 8, okay? But 18 minus 10 is still 8 as well. So we're going to take the first three terms here and we'll equate it to the following. So 2a is equal to 8, 3a plus b is equal to 10, and then a plus b plus c is equal to 3. So we'll say 2a is equal to 8, therefore a is equal to 4, and then 3a, which is 4, plus b is equal to, and it's equal to 10. And then solve for b. b is equal to, you can just transpose this. This will become 12. So 10 minus 12 is negative 2. And then a plus b plus c. So that is 4 minus 2, so plus negative 2 plus c equals this first term of 3. So it's equal to 3. C is equal to 4 minus 2 is 2. And if you transpose, it becomes negative 2. So 2 minus 3 is 1. And that is our answer. So we'll say Tn is equal to A is 4, so 4n squared. B is negative 2, then n, and then lastly plus C, which is plus 1. And that is the formula. Moving on to the next question. Question 2.3 says, given and we have 2, 3, 5, 6, 8, and 12, we need to determine the next two terms in the sequence. Okay. Let's see what our terms look like and just, look for consistency in this pattern. So 2, 3, 5, 6, 8, and 12. And looking at it, I was like, maybe this is a quadratic, because we're not seeing a clear consistency with the numbers. So let's see the differences that it gives us. If you say 3 minus 2, you get 1. 5 minus 3, you get 2. 6 minus 5, you get 1. 8 minus 6, you get 2. And then this, you get 4. So 1, 2, 1, 2, 4. No, that can't be the pattern. Okay, the minute the thing starts getting weird and complicated, it's probably not as complicated as it looks. And so this is a very old type of question. It's actually something that it used to be there. So maybe questions before, I would say, maybe 2018 and back, right? It's probably a question where we have two patterns, okay, two separate patterns. So let's look at them separately, as in this is probably a pattern alone, and then this is, okay, one pattern, and then the blues are another pattern. And now do you see consistency? The 3, 6, 12. If you said from 3 to 6, we're clearly not adding. From 3 to 6, you would say 3 multiplied by 2. To get to 6. And then from 6 to 12, you would say 6 multiplied by 2 to get 12. Okay, so that's the pattern there. So that one is geometric, okay? Previous term multiplied by 2. And then this, what consistency can we see here? 2, 5, 8. So we are adding here because, can't multiply by 2 and then get 5 and then multiply the same thing and get 8. So 5 minus 2 is 3 and 8 minus 5 is 3. Okay, so these are two patterns. The reds are linear or arithmetic, and then the blues are geometric. Okay, arithmetic. And this is geometric. So to find the next terms, if it ended with a geometric, the next term is going to be part of the arithmetic. And then the next term would be geometric. Okay, so we can simply find the next two terms by saying this red one is going to be, because we keep adding by 3, 8 plus 3 equals 11. So the next term is 11. And then in the geometric, we have 12. We keep multiplying by 2. So multiply by 2 is 24. And that is our answer. Moving on to the next question. Question 2.3.2 says, determine the sum of the first 39 terms. So there needs to be 39 terms in total, despite the fact that we have a mix of arithmetic and geometric patterns. Let's figure out how these 39 terms will be formed. So we'll have a column for the arithmetic pattern, and we'll have a column for the geometric pattern. And we're going to find the sum of them separately, not 39 terms in each. No, they need to add up to 39 terms in total. But we need to find out how many terms are arithmetic and how many would be geometric. Okay, let's think about it like this. In our pattern above, we started off with the arithmetic, okay? So the arithmetic are, see it like this, okay? So we're going to look at them as term values. Okay, let me rewrite this again, okay? And I'll just write it above this because we need to see how many terms we have in total in each. So let me rewrite it first. Okay, so the geometrics are blue, the arithmetics are red. So if we're looking at the general term numbers, right? Do you see that this is term 1, this is term 2, term 3, 4, 5, and 6. What do you notice about the arithmetic terms and their term numbers? They lie in term numbers that are odd. See, T1, T3, T5. Those are odd numbers. And then the geometric, they lie in term numbers that are even. Term 2, term 4, term 6. So we can see that if we have 39 terms in total. Okay, let me get more space. Okay, so if this is what this looks like, it will be easier to find this with the even term numbers. Here's the thing. Yes, these are their positions based on this pattern, but remember that they form a different pattern when you look at them as these are the terms in your geometric pattern and these are the terms in your arithmetic pattern. So in the geometric pattern, I'm going to target the even term numbers because look at how this works. In the first term in this geometric pattern, right? This is the first term for the geometric pattern. This stands as the second term for the geometric pattern, okay? Now, do you see that the first term is at term 2 of the general pattern? The second term is at term 4 of the general pattern. We know that this ends at exactly 39 terms. So it means that term 39 is an odd number. So this means that it's not going to belong to the geometric pattern because the geometric pattern has even term numbers, okay, 2, 4, 6. So that is going to end on an arithmetic term value. So that means the previous one, term 38, okay, that would be a geometric. And now we can use this to find out exactly how many terms there are in the geometric first, and then we will know how many terms there are in the arithmetic. Okay, so you can see that whatever term number it belongs to in the geometric pattern, in the general term, it's just double of that. So if this is 38 in the general term, then what term number is it in the geometric pattern? This would be 38 divided by 2. So if you say 38 divided by 2, that is 19. Okay, so this is term 19 of the geometric pattern. So it means in our geometric pattern, we have terms from 1 to 19. Okay, and then term 3, and then all the way to term 19. We have 19 values. And I'll also put them down because we need them. 3, 6, 12, and, the 19th one. Now, why is this important? If you know that there are exactly 19 terms in the geometric pattern, and this first 39 terms is referring to all these terms being added, then just say 39 minus these 19 terms, and that will give you the total amount of arithmetic term values you have. So that is 20. So it means that there are 20 terms in the arithmetic pattern. So this is term 20. Okay, so that's term 20. So there are exactly 20 terms here. So we can just see this as this is term 1, term 2, term 3, and then it ends at term 20. Okay, there we go. 20 terms plus 19 terms give us our total 39 terms. Okay, so we can also put that down. That is 2, that is 5, and 8, and then we don't know that one. And now we can finally find the general term. Because we don't know the last terms in this one, the last term, I'm just going to go ahead and use this formula. So the sum of terms is equal to n over 2 multiplied by 2a plus n minus 1 times d. And so it's the sum of how many terms in the arithmetic pattern? It's the sum of 20 terms. So 20 is equal to, and we'll say 20 over 2, and then 2 times a. What is the first term in the arithmetic pattern? It's 2. And then plus 20 minus 1. And the difference, we saw that was 3 that we kept adding to each successive term. So multiply by 3, and that will give us the sum of the 20 terms in our arithmetic pattern, which is a total of 610. We'll hold on to that. And then we need to do the same for the geometric. But this is geometric. And we saw that what we kept multiplying by was 2. Okay, keep multiplying each term by 2. So yeah, these are things that we should state. Well, we already inputted it, so it's fine. I should have said D is equal to 3 here. A is equal to 2. Here, the first term is 3. And we see that the common ratio, what we kept multiplying to get to the next term, is 2. We kept saying times 2, and you get 6. Times 2, you get 12. Okay, so now we know that R is greater than 1. So I'm going to use this formula. Sn is equal to A multiplied by R raised to the power of n minus 1 all over R minus 1. Okay, this is where R is greater than 1. Okay, so the sum of how many terms here? That's 19 terms that we have. So the sum of 19 terms is equal to 3 multiplied by, the ratio is 2 raised to the power of 19 minus 1 all over 2 minus 1. And then we'll just find the sum of these 19 terms. Okay, and that is equal to, so that is 1,572,861. And so, to find the total number of terms, okay, the total sum of our terms, of the 39 terms, we're just going to say the 610 plus the 1,572,861, and that will be our answer. So just add to this, we're just going to say plus 610. And so therefore, the sum of 39 terms is equal to 1,573,471. And that is our answer. Okay, moving on to the next question. Question 2.4 says, write the following series in sigma notation. Okay, so with this pattern, do you see that the only change we're seeing is in these numerators? So 64, then we have negative 32, and then positive 16, and then negative 8. Okay, so that is where the pattern is. And let's just try to see what kind of pattern this is. 64 minus 32 plus 16 minus 8. Okay, 64, half of 64 is 32, half of 32 is 16. So we can see that to get the next term, we're simply multiplying by negative a half. Okay, so that would be the ratio. This is clearly a geometric series. And we have to write this series. Okay, we should also remember that divided by 5, but we need to write this in sigma notation. And they say to n terms. Okay, so here's what we have. We're just going to have to find, in order to put it in sigma notation, we need to find the general term of the series. So it is geometric, so we can use Tn is equal to A multiplied by R raised to the power of n minus 1. Okay, so with this, because they say two n terms, and I know that we're going to end at n, I'm not really going to call this n. Let's just call it something else. You can call it TP, okay, or really anything, any other variable. I'll just call it TP is equal to, and then we have 64 multiplied by negative a half raised to the power of p minus 1. And so just writing it in sigma notation, we're simply going to say this is the sum of the series starting where, and we're starting at this first term. If you substitute 1 in place of p, you're going to just get 64. So we'll say starting where p equals 1, and then now ending at n, because they say two n terms. If they said two 10 terms, we would have to put 10 up there. But they say two n terms, so I'll just put n here. And that's the reason I didn't want to put it down here, because if you have Tn is equal to, and then you put that, that would represent the last term, technically, because the last term's number is n. Okay, so this is what this looks like, and then we'll put down our series in here. Okay, the general term, which is 64 multiplied by negative a half raised to the power of p minus 1. But then remember that this series, right, keeps going, and we have divided by 5. So all of this will be divided by 5. And we could write it like this, or we could simplify it further, so it will look like this instead. Okay, so it is the sum. We have where p is equal to 1, starts at 1, ends at n, and then we can put the 64 over the 5. So we can write it as 64 over 5 multiplied by negative a half raised to the power of p minus 1. And there we go. So that would be the series in sigma notation. Moving on to the next question. And then question 2.5 says, the numbers 7, x, and y forms a geometric sequence if the sum of these three numbers is negative 2x minus 7. Okay, so these numbers, 7, x, and y, they form a geometric sequence. But they also tell us that the sum of these three numbers is negative 2x minus 7. Determine the possible values of x and y. Okay, so this is a simultaneous equation. We're trying to solve for x and y simultaneously. Let's take the first information they told us. This forms a geometric sequence. What can we do with that? If they tell you that it forms a geometric sequence, the only equation that you can create using this information is the equation found by finding the constant ratio, because that's something we know about the geometric sequence. Its ratio is constant, meaning r would be found by saying term 2 divided by term 1, but it will also be found by saying term 3 divided by term 2, meaning r and r should still be constant since it's geometric. So we're saying that x over 7 should still be equal to y over x. Of course, I will keep in mind that x should not be equal to 0 because of this. And so if you cross multiply, you have x squared is equal to, and cross multiply here, you have 7y. Okay, so this is one equation we have. What other information did they give us? They said that the sum of the numbers, okay, give us this, meaning 7 plus x plus y is equal to negative 2x minus 7. So we can go ahead and simplify this further. We can leave y on this side. Y is equal to, and if you transpose x, it becomes negative 2x minus x, which is negative 3x, and the negative 7 minus 7 is negative 14. So I'll go ahead and call this equation 1, and I'll call this one equation number 2. That way we can substitute wherever we see y. Here in this equation, we will substitute negative 3x minus 14. So substitute equation 1 into equation 2. So now we have x squared is equal to 7y. So that means that if we substitute, we have x squared is equal to 7 times negative 3x minus 14. And so x squared is equal to, that will give us negative 21x. And then what's 14 times 7? That gives us, okay, 28. And then 7, 9. Okay, so 98. Negative 98. And this is a trinomial. So x squared, and we can transpose these, becomes positive 21x and positive 98 is equal to 0. Then we have to factorize. Okay, so factors of 98, that can give us 21. So I'll write 98 is equal to shift fact. Okay, so use the fact button. And I get 49 and 2. That can't give 21. But we can see this as 7 times, if you say 2 times 7, you get 14. So can 14 and 7 give us 21? Yes, they can. Okay, so I'm splitting it up really as 2 times 7 times 7. And then I just decided to pair this together to get 14. Okay, so yes, we know that if you say 14 plus 7, you do indeed get 21. So it means x times x gives us x squared. And then it is positive 14 times positive 7 that give us that 98. But when added, they give us 21. So it means that x is either equal to negative 14 or x is equal to negative 7. Okay, and now that we found x, we can simply find y. So you can just use the equation that had y as a subject. So y is finally equal to, and that is negative 3x minus 14. So negative 3x minus 14. So if this is negative 14, or y is equal to negative 3, and this is the second x value, negative 7, and then minus 14. And I'm just quickly going to use a calculator to find these values. Okay, so the first is 28. And if we substitute negative 7, we get 7. Okay, so these are our answers to this simultaneous equation. X is equal to negative 14, while y is equal to 28, or x is equal to negative 7, while y is equal to positive 7. And that is it for question 2. Question 3 says, given f of x is equal to the square root of x over a, where x is less than or equal to 0, the point P, which is negative 8 and 2, lies on the graph of f. Determine the value of a. Okay, so let's take this point and substitute it into this equation. So if we have the square root of x over a, and P is a point that lies on this graph, so the x value is negative 8 and the y value is 2. So 2 is equal to, and we're saying the square root of negative 8 over a. So to solve for a, we can just square both hand sides to get rid of the square root. And now we have 4 is equal to, and that breaks open, we have negative 8 over a. Okay, you can just cross multiply or transpose the 8, but if you cross multiply, just put this over 1. 4 times a is 4a, and 1 times 8 is negative 8. If you divide both hand sides of the equation by 4, a is simply equal to negative 2, and that is our answer. Moving on to the next question. Okay, question 3.2 says, determine the inverse of graph f. So to find the inverse, we first need the equation of f, and we'll just fill in the value of a. So we can call this y is equal to, and we have the square root of x over negative 2. Okay, so x over negative 2, and then we need to swap x and y to find the inverse. So in place of y, say x is equal to the square root of, in place of x, say y, and then over negative 2. Okay, so now you have to make y the subject. So to get y on its own, you see that something that is stopping us right now is the square root. So we need to get rid of it, and we can do so by squaring both hand sides of the equation. So now we have x squared is equal to, and this is y over negative 2. To make y the subject, we can multiply both hand sides of the equation by negative 2, and therefore y is equal to, this is just going to be negative 2x squared. Of course, we can tell them the domain, and we could have also just set the constraints all through here, but they didn't really specify that we needed to. So we can just tell them the values of x for which this graph will exist, because the original graph, okay, this was restricted. So the original graph's domain was x is less than or equal to 0. So let's think about what this one is going to look like. This graph, it's the inverse of a parabola, really, okay? But we're looking at that as the original. So this is what it looks like, and it's restricted right there at 0. So it's that graph that is at the origin. It has a turning point at the origin. We can see that the parabola would be concave down. So it's concave down and it looks like this. But we need to see which one would exist. If it is concave down like this, okay, this is the inverse. I have to actually call it the inverse. This is the inverse. And then the graph of f, that was this graph. Okay, technically the inverse of a parabola. Okay, what that one would look like depends on what this one looks like. So if this one is concave down, okay, towards the negative part of the y-axis, this one, the inverse, will also be concave down, but towards the negative part of the x-axis. So it ends up looking like this. Okay, it ends up looking like that. Now, what they told us was that the values of x for which this exists was where x was less than or equal to 0. But here is the thing. You see, with these graphs, you need to understand the relationship between the original and the inverse. Okay, so we can look at the domain and the range. So in the original graph, we were told that x is less than or equal to 0, right? Now we know that the range of the original, we know what that is. And the reason why we would know is because they told us that there was a point called negative 8 and 2. Negative 8 and 2 lies on this blue graph, right? This is our original graph. If negative 8 and 2 lies on this, let's see where that will be. Negative 8 on the x-axis, so we'll go 8 units to the left, and 2 going up. So that means the part of the graph that exists, if this is negative 8 and 2, would be this section, okay? This part is the one that was cut off. So if this is the part of the graph that exists, okay, then this restriction will affect this inverse, okay? So we can clearly see here that the range of the original is where y is greater than or equal to 0. You see that this will only have values of y that are either equal to 0 or values greater than 0. That's where we have y values here. Okay, so we can say this is where y is greater than or equal to 0. And then this is how we find the domain of this. The relationship between the original and the inverse graph works like this. You see, the same way x and y swap is the same way the domain and the range will also swap. So if the original's domain was x is less than or equal to 0, the inverse's range will be y is less than or equal to 0. And then if the original's range was y is greater than or equal to 0, this will make the inverse's domain x is greater than or equal to 0. This is something that you need to always keep in mind with the inverse function and the original. So all this means is that this is where this graph exists, specifically where x is greater than or equal to 0. And this is our answer. Remember, this will be much faster for you to think about in your head than actually, writing it out and explaining it. Okay, moving on to the next question. Question 3.3 says, sketch both the graphs of f and the inverse on the same set of axes and show at least one point and the intercepts for each graph. We already have a rough idea of what it's going to look like, but let's put down our Cartesian plane first. Okay, and you see that where you get that rough idea is when you start to consider what that domain is, okay? Because you see that the original had a domain, so you need to also state that for the inverse. So we know now that the original graph looks like this because they told us about a point that lies on the graph. Okay, so -8 and 2. So the original graph looks like this. Okay, concave down parabola like that, but only half of it, of course. And we have that point, so we can just put that point over there. That was P, and we know that that was -8 and 2. So now we know that the inverse would look like this. Okay, so you see that whole story with drawing the parabola like that, and then we knew that, okay, this one is also concave down. Okay, but of course I started with this one. So we know now what this one looks like, but you now need to decide on which wing would stay. Is it this wing over here or this wing? You're going to see that by looking at this information, the relationship between the domain and range of your original and your inverse graph. If this is what we have, right? And we know that this is the inverse. Yes, I know it's a parabola, but remember it is still the inverse because they told us the original was this graph. Okay, so let's look at the information about the inverse. We know that its domain is x is greater than or equal to 0. And that already tells us everything. Okay, the range was y is less than or equal to 0. Do you see that where the y values of this graph are less than or equal to 0 is all through here? It only has negative y values. See, look at that. It's a negative y value, negative, all through. But we also found out that x is greater than or equal to 0, meaning if you look at this side, look at the values of x that this exists for. These would be values of x that are equal to 0, but less than 0 as well, okay? Equal to or less than 0, or less than or equal to 0. But we can't take that because we know our domain of the inverse is x is greater than or equal to 0. So this is the part that would stay, and that's what we would draw. Okay, so we're simply just drawing our parabola like that. Make sure it touches that origin. And so there we go. And now we have a point, right, on both graphs at the origin because you saw how it was restricted from the origin. So both their turning points was at 0. So we can say that's 0 and 0. And now we can also just draw this point, okay, and what it would look like on the inverse. So this is the original graph f. This is the inverse. And this point wouldn't be -8 and 2. It would be 2 and -8. So we can just put that down and say this is, I'll call it P prime. This is 2 and -8. And that is what our graphs would look like. Okay, there we go. We show them the x-intercept, which is also a turning point. And we've shown another point using this point that they already told us. Moving on to the next question. Question 3.4 says, if P is reflected, if P is reflected in the line y equals -2, determine the coordinates of P prime, the image of P. Okay, I'm just going to change that. Let's call it something else. Or let's just not call it anything. Let's just put it as P. And this is the other point on that graph. So P prime. You don't need the graph for this, okay? It may seem like you need the graph because these are points that are on F, but you actually don't need the graph for this. Think about it like this. P is that point, -8 and 2, right? Let's say P was here. Let's just mark it in red. If this is P, -8 and 2, and they're telling us that this point, it's just a point that is reflected across this line y equals -2. Well, what does that line y equals -2 look like? It's y equals, meaning it's passing a particular y value. It's passing -2 on the y-axis, and then its equation is y equals -2. So if a point is being reflected across a line, it really just means that, see this point is here, P, it's going to appear over here. But we can't just say, oh, it appears here and then just guess where it is. Here is how reflections work. And for that, we need to know what this y value is. P's y value is specifically 2. When you reflect a point across a line, what it means is that if you travel from that point to the line that it was reflected across, the new point that was reflected is going to be at the exact same distance as from the line it was reflected from to this new point. So their distance will be exactly the same, and that's how you would know this was reflected across this line. So the distance between this line y equals -2 and this point P is what? That distance is, this is -2, this is 2. The distance there is 4. You can say 2 minus -2. But you can also see it as I went 1 unit up to get to 0, and then 1 unit and 1 unit to get to 2. So that's 4, right? 4 units. So the distance from this line to this new point will also be 4 units. If we know that this is a reflection, okay, it's going to be vertically in line with this reflected point. So P prime, its x value is also -8. And what is its y value now? Well, it's going from this point with a y value of -2, and it's going exactly 4 units down. Okay, that distance is still 4. So what is -2 minus 4? That is -6, and that is our point. P prime is simply -8 and -6, and that is our answer, and that is it for question 3. Question 4 says, in the diagram below, the graphs of f of x, which is equal to 2p to the power of x, plus q. Okay, so this is the graph of f, and we can see that this is an exponential function. You see how it gets closer and closer to a horizontal asymptote. Okay, and then g of x is equal to log of x to the base of t, and this is a logarithmic function that we have here. And we can see that because it gets closer and closer to this y-axis. Okay, so it has a vertical asymptote. Okay, and that these are given. They tell us that O represents the origin. And then they tell us that the graphs have a common x-intercept at C. Okay. The graph of f has a y-intercept at D. The asymptote of f, the asymptote of f and the graph of G both pass through A, which is 2 and -1. Okay. So if the asymptote of f, and I'm already going to put this down since they're saying so, if this line passes through this point, 2 and -1, it means its x value is 2 and its y value is -1, meaning we know what the equation of this horizontal asymptote is. I'll just keep that there. Now, this is also a point that lies on G. Okay, so this lies on G. Great. And then they also tell us that B is a point on F. B is a point on F. Okay, that's on F. And lastly, EBA is a line perpendicular to the x-axis with E on the x-axis. If this is a line perpendicular to the x-axis, it is a vertical line. And so you can see it will be vertically in line with this point, meaning it shares a what coordinate with this point? It would share an x coordinate. Okay, so you can already see what the x coordinate of E is. And really the full coordinates of E, since it lies on the x-axis. And the first question is to determine the value of t in g of x is equal to log of x to the base of t. Okay, so on the graph of G, we have 1 point. We have this point A, okay, that lies on this graph, but the asymptote of f passes it. So we can simply just take g of x is equal to, and we'll just say log, and our base is t, and we have x, and we're going to substitute a in place of x and y. So our y value is -1, which is equal to, and we have log, and our base is still t, and the x value we have is 2. Now, to solve for this, you can simply put it back in exponential form. So our base is 2. Our exponent is -1 because log makes the exponent the subject. So to the power of -1 is equal to 2. Okay, so how do we solve for this? Or how would you make those exponents the same? We can rewrite 2 as an exponent of -1. If this is t to the power of -1, 2 can be written as 1 over 2 raised to the power of -1. So therefore, this means that t is simply equal to a half, and that is our answer. Moving on to the next question. Question 4.2 says, write down the coordinates of C. This is an x-intercept. So how do you find this? You make y equal to 0. So we're going to say, okay, y is equal to 0, and we'll take our graph as it is. It's now going to be g of x is now equal to log, and our base is now 1 over 2, and then you just make y equal to 0. So 0 equals log and x to the base of 1 over 2, and then just rewrite in exponential form to solve for this. So this would mean that we have 1 over 2 to the power of, this is our exponent, 0 is equal to x, and anything to the power of 0 is 1. So therefore, we can see that C is simply 1 and 0, and that is our answer. Moving on to the next question. Question 4.3 says, determine the value of P, and we need to show all our working. So P is simply just this, okay, that base. How do we find the base? Well, we could just find the full equation because we know what Q is now. Remember the whole story with that asymptote passing this point A to a -1. So we know that this asymptote is y equals -1, okay? The asymptote of F. And so that means that the Q value, that stands for your horizontal asymptote, that is -1. So we could rewrite that first. We have f of x equal to, and that was 2p raised to the power of x, and we have -1 now, okay, because we know that q is equal to -1. And so with this equation, the only thing missing is p. So if you had 1 point on the graph of f, you can use it to find p. And we do have 1 point on the graph of f. It's the point we previously found, c, which is a common x-intercept between both graphs. So we can just substitute c. Its y value is 0, its x value is 1. So 2p raised to the power of 1 minus 1. Okay, so it means that to find p, transpose this 1, it's now 1 is equal to 2p, and divide both sides by 2. Therefore, p is simply equal to 1 over 2. And that is our answer. Moving on to the next question. The next question says, determine the coordinates of D. Where is D? D is on the y-axis, and it passes through this graph F. Okay, so it's the y-intercept of F. We already have our equation of F. We can just fill in P there. So the equation of F of x is simply equal to, and we have 2 multiplied by a half raised to the power of x minus 1. Okay, completing it just like that. And we're just trying to find D, which is the y-intercept. To find the y-intercept, you simply make x equal to 0. So this is f of, and in place of x we'll say 0. F of 0 equals 2 multiplied by 1 over 2 raised to the power of 0 minus 1. Okay, anything to the power of 0 is 1. 2 times 1 is 2 minus 1 is 1. So f of 0 is simply equal to 1. And so D, the coordinates of D, the y-intercept is 0 and 1. And that is our answer. Moving on to the next question. Question 4.5 says, calculate the length of AB. Okay, so length of AB. If this is, okay, so you see that A, this lies on a vertical line. So to find the length of this, if we knew exactly what the y value of B is, we could simply say that y value minus this y value of -1. And we would find the length, okay, the length of AB, which is just this distance. That is AB. Okay, so the main goal right now is just to find this coordinate B, or at least its y coordinate. That's all we need. So B lies on which graph? It lies on the graph of F. Okay, as we can see, it's on the graph of F. So B is also on this vertical line, and this vertical line also has this point A, 2 and -1. So it would mean that because they are on the same vertical line, they share the same x value. Okay, so B's x value is 2. We just need to find its y value. And that's what we're going to do using the graph of f. Okay, so let me take down the graph of f. And we're just trying to find out the y value that belongs to this x value of 2 on the graph of f. So that is going to be, we're going to just change that to 2. So this is f of 2. And let's see what we get here. So f of 2 is equal to, that will become a quarter times 2. And so 2 cancels and 2 cancels. You're left with 2 here. So this is just a half minus 1, which is negative a half. Okay, so it means that the point B is simply 2 and negative a half. Great. Now, I don't really need the full point. I'm not really bothered about the full point. I just want the y value of it. So I know that the y value of B is negative a half. So to find AB, we'll simply say, now that we know this is negative 1 over 2, to find this distance or this length, we'll say the higher y value minus the lower y value. Okay, so that is negative a half minus negative 1. So just tell them that to find AB, we simply say AB is equal to negative a half minus negative 1. So that becomes plus. And what is a half plus 1? That's like saying 1 minus a half, which is a half. And so the length of AB is simply equal to a half units. And that is our answer. Moving on to the next question. Question 4.6 says, write down the range of f. The range is really just all the y values of this graph. So let's look at where all the y values of the graph of f lies. You can just use the graph for this. So look at the graph of f. You see that it reaches this, well, it doesn't reach this point, but we have an asymptote at y equals negative 1. So the graph will never go below y equals negative 1. All the y values would start immediately after negative 1, and it will be everything up here. Okay, this graph of f is only going to have values like that. If you map its points to y values, it will be everything that is greater than negative 1. Okay, so our answer there is simply that the range of f is y is greater than negative 1. And that is our answer. You can also write it in intervals, and that would look like this. If you're saying that y is greater than negative 1, you can look at this on a number line. If this is negative 1, values greater than negative 1 are on this side. So you're saying y is an element of, and you're starting at the smaller y value. The smaller y value or the beginning point would be negative 1, and then the higher y value, because we're moving to the right, this is heading towards positive infinity. Okay, infinity is not a fixed value, so we use a round bracket. But here we will also use a round bracket. The reason why is because y is greater than negative 1, not greater or equal to negative 1. Okay, we don't have a y value at negative 1 because there's an asymptote there. So the graph will never pass this. Okay, so you can write it like this or like this. It's perfectly fine. So that is it for this question. Moving on to the next question. Question 4.7 says, determine the value or values of x for which g of x is greater than or equal to negative 3 over 2. Okay, we can just first find out where g of x is equal to negative 3 over 2, so we can use the graph to find out where it is greater than or equal to negative 3 over 2. So remember that the graph of g, that was the log graph. Okay, this is the equation. Okay, so we're saying, where is this graph? Where does it have a value equal to negative 3 over 2? To solve for this, or to solve for x, we need to put it back in exponential form so we can find this. So we'll say the base, which is a half, raised to the power of the exponent, which is the subject. So that is raised to the power of negative 3 over 2 is equal to x. Okay, and so what is this? You can use a calculator, but you could also just solve it like this. You see, when you have a rational number as your exponent and you have a base, it means that this can be written as a surd. Okay, so it works like this. We'll take the inside exponent over the outside exponent. So as a surd, it means that this the outside exponent was a 2, meaning it's a square root. And then the base that we have is 1 over 2, and the inside exponent was a negative 3. If you raise 1 over 2 to the power of negative 3, you're going to get 8, okay, because of what happens with the negatives, okay? That's going to be 1 to the power of negative 3, 2 to the power of negative 3, but the exponents are negative. So you would have to move that base of 2 to the numerator and this base of 1 to the denominator, giving you 2 to the power of positive 3 over 1 to the power of positive 3. And so that's 8 over 1, okay? So that's how we will end up getting that this is actually equal to the square root of 8. And square root of 8, as I said, is simply just 2 square root 2, okay? Because we have square root of 8 can be 4 times 2, but the square root of 4 is 2. Okay, so this is what we have. X is equal to 2 root 2. Okay, and let's go ahead and find out where this graph is greater than or equal to this value, if the x value is 2 square root 2. Okay, so the graph of g, this is the graph of g that we have. Let me just get rid of some of these annotations. Okay, so this is our graph of g, right? And we're trying to find out where is it greater than or equal to negative 3 over 2. So negative 3 over 2 is negative 1.5. Meaning, if this is negative 1, negative 1.5 is maybe somewhere here, right? And I think I'll just make it closer just so that I can actually do this. So here is a horizontal line to mark this. This point over here is the point that has a y value of negative 1.5 and an x value of, we just found that that is 2 square root 2. So we need to find out where g of x has values that are greater than or equal to negative 3 over 2, which is negative 1.5. So below here, all the y values of this graph are less than negative 1.5, negative 3 over 2, right? But we need them to be greater than this. So where are they greater than this? If you map this to your graph, you will see that this happens all through here. So starting at 2 root 2, and then everything here, okay? Everything above this line, basically. So we can just line this to the x-axis to better understand these values. If you line all of these parts to the x-axis, you see that these are values that are, clearly there's a limit here, okay? We cannot go beyond this y-axis. It won't go beyond it because there's a vertical asymptote here. So the vertical asymptote lies at x equals 0. And now we can see that where the graph has y values greater than or equal to negative 3 over 2 is where x is greater than 0, but less than or equal to 2 square root 2. And that is our answer. We're just going to tell them this is simply where x is greater than 0, but less than or equal to 2 square root 2. And that is our answer. You can write it, of course, in intervals, which would just be x is an element of, you're starting at 0, ending at 2 root 2, but x is actually equal to 2 root 2, so you use a square bracket there, and it's not equal to 0, it's just values immediately greater than 0, so use a round bracket. So you can write it like this or like that, and the answer will be fine. And that is it for question 4. Question 5, 5.1 says, simplify, and we've been given this trigonometric expression, and we need to simplify this for 7 marks. Okay, so with this expression, do you see that with sine negative theta, and let's just put the cos diagram down here. So with this sine negative theta, do you see that theta is negative? So when our angle is negative, we can simply just add 360 degrees to this. So this will become sine 360 degrees minus theta, which we can see is in cos's quadrant, and sine is negative in this quadrant, so it will reduce to negative sine theta. And then we are multiplying by cos 420 degrees. The angle that we have here is just over 360 degrees, and when our angle is over 360, we simply subtract by 360 degrees. And 420 minus 360 is 60, so this is actually cos 60 degrees, okay, which we can still change using one of the rules for special angles. And then we have multiplied by 540 minus theta. Again, this is an angle over 360. Simply just subtract by 360 degrees, which is sine, and that is 180 degrees minus theta, and then multiply by sine 20 degrees. Okay, so maybe that will have a cofunction, but for now we'll just leave it as sine 20 degrees. Okay, it will definitely with this. So we'll leave it as sine 20 degrees, and then we'll just reduce that one. Okay, and this goes all over, and we have tan squared negative 120 degrees. Simply just add 360 degrees to this since it's a negative angle, and so we will have tan squared, and that is going to be 360 minus 120 is 240 degrees. Okay, so cos, and then now we have to reduce that angle. It's not over 360, but it can be reduced. If you look at your cos diagram, where will it lie? Okay, this is our cos diagram. It is an angle that is greater than 180 degrees but less than 270. So it's in tan quadrant, and so we can use this reduction to reduce it. Okay, so cos 250 degrees would be reduced by saying 180 degrees plus what gives you 250, and that is 70 degrees. Okay, so that makes sense now. And if you reduce it, of course, we will get the answer. But you can reduce it at this point straight away. This is just a slow method. So if we have 180 degrees plus 70 degrees, then you see that that is in tan quadrant. So it's going to reduce to negative cos of 70 degrees. So negative cos 70 degrees. Also just keep in mind that these two are actually multiplying. So they're still multiplying. Okay, so in the numerator, what do we have? We have negative sine theta, and we have cos 60 degrees. You can decide to use your calculator or the cos diagram, but with this, it's actually really simple. Sine 30 degrees and cos 60 degrees both give a half. So we're multiplying by a half, and then sine 180 degrees minus theta, that will just stay positive sine theta. And now we have sine 20 degrees. We can leave that the same, and then we can use cofunctions to change this to sine 20 degrees, since 70 plus 20 give us 90 degrees. So these are cofunctions. Okay, and so this is what we have now. So multiply by sine 20 degrees, we'll leave that just as it is. And now in the denominator, what is tan 240 degrees? Well, 240 degrees, again, it's greater than 180 but less than 270. So this is just going to be tan squared of, and the reduction would be 180 degrees plus 60 degrees is what gives us 240. Okay, so it's multiplied by negative cos 70 degrees. But we can just change this cos 70 degrees using cofunctions. So 70 degrees is less than 90 degrees. So we can change that to sine 20 degrees. Okay, so it's just going to change to whatever 90 degrees minus 70 is. And so now that is sine 20 degrees. It's still negative, of course. Okay, so this is equal to, and now seeing how they're all multiplying through, this is just negative. So keep in mind that it is negative. This sine 20 cancels with sine 20 degrees as well. And then these two, they're both sine, so they'll become squared. So here in the numerator, we have negative a half sine squared theta, and then over, and now when we reduce this, this is in tan quadrant, so it's going to give us a positive tan 60 degrees, but it's tan squared, so it's still squared. So what is tan 60 degrees? Tan 60 on the calculator, and really even with any rule, is still going to be the square root of 3. Okay, so it's still square root 3. We can just rewrite it like that. So this is root 3 all squared, okay, because it's going to be squared at the end of the day. And then this is just going to be equal to, they were both negative. I forgot about that negative. It's still on the outside. Okay, so the negatives will cancel at the end of the day. And now you just have a half sine squared theta divided by the square root of 3 all squared. So that would just become 3. So we're just dividing by 3. Now 3 can be written as a fraction as 3 over 1. And so we can use tip and times on this. So it's just going to become multiplied by 1 over 3. Okay, we switch the numerator and denominator and change the division to a multiplication. So in a nutshell, remember sine squared is really in the numerator. You can't just rewrite this as sine squared theta over 2. So numerators multiply, and that is sine squared theta and then over 6. Okay, you can rewrite this as well as 1 over 6 sine squared theta, and that's also fine. So that is it for this question. Moving on to the next question. Question 5.2 says, if 3 tan theta minus 4 is equal to 0, and theta is an element of 90 degrees to 360 degrees, determine the following without the use of a calculator. And we have to determine the value of cos theta. Well, from the information they're giving you, they're telling you about a quadrant that this terminal arm lies in. So we have a trig diagram, and let's just see. So with this trig diagram, we are told that 3 tan theta minus 4 is equal to 0. Well, let's find out what tan theta is. Okay, what ratio is that going to give us? So transpose the 4, okay, and so tan theta equals positive 4, divide both sides by 3, and therefore tan theta will simply be equal to 4 over 3. Okay, so tan theta is a positive value. So where is tan positive in our quadrants? Tan is positive in the first and in the third quadrant, in 10th quadrant. And they also tell us that theta is an element of 90 degrees to 360 degrees. So if we're counting these, remember, this is 0, this is 90, 180, 270, and then back at 360. So if we mark all the quadrants between 90 degrees and 360 degrees, we'll start here. So 90 degrees to 360 degrees are these three quadrants. Okay, but you see now that the only quadrant that satisfies both requirements, okay, that tan is positive and it lies between these quadrants, would be the third quadrant. Okay, it's the one with 2 ticks. So that's what we're going to take. We're going to go ahead and draw our terminal arm in the third quadrant. Okay, so then draw a line, okay, to the x-axis and perpendicular to that x-axis. And we are told that tan theta is equal to 4 over 3. Now, from SOHCAHTOA and from the positions of our sides relative to the angle, we know that tan is opposite over adjacent, okay, TOA. And so, because of this, it means that 4 is the opposite and 3 is the adjacent side. So if this is theta that we're measuring like this, okay, from here at 0 degrees all the way here, okay, this reflex angle, and we know that this is theta, then the opposite side is 4 and the adjacent side is 3. Now, this is that case that you have to watch out for, because do you see that 3 is on the negative part of the x-axis? So this should be negative 3. And 4 is on the negative part of the y-axis, okay? It's pointing at this negative value. So it should be negative 4. And so what happened is they had negative 4 over negative 3, and it's simplified to positive 4 over 3. Always watch out for that. So you see now that all we need to find is that hypotenuse. Okay, so how do we find the hypotenuse? It's r, okay, the radius. R squared is equal to, we just use Pythagoras. So the shorter side squared plus the other shorter side squared. And then we'll just find this. Okay, so r squared is equal to, that's going to be 9 plus 16, which is 25. And if you square root both hand sides, then r is finally equal to 5. And you don't have to consider the negative because it's a radius. So it is a length, it cannot be negative. Okay, so this is 5 units. Great. And now we can find the value of cos theta. So cos theta is therefore equal to, from SOHCAHTOA again, cos theta is adjacent over hypotenuse. So the adjacent side, the side adjacent this angle is negative 3 over, and the hypotenuse is 5. And that is our answer. Negative 3 over 5. Moving on to the next question. Question 5.2.2, we have to find the value of sine 2 theta. Okay, so theta is defined here in this third quadrant. So we're going to have to use double angles so that we can get some thetas and we can find this. So this is equal to, because we're using double angles, it's going to be 2 sine theta cos theta. And so all we have to do is say 2 multiplied by what is sine theta. Sine from SOHCAHTOA is opposite over hypotenuse. So it's the opposite side, negative 4 over 5. So negative 4 over 5 multiplied by cos theta, which we found previously is negative 3 over 5. So this is simply equal to, we're going to have all the numerators multiply. Notice this is in the numerator. It has a natural denominator of 1. So this is 2 times 4, which is 8. 8 times 3 is 24. So they're going to still be positive because these two are negative, so they multiply. So we have positive 24 over, and our denominator is 25. And that is the answer of sine 2 theta. Moving on to the next question. Question 5.2.3 says we have to find the value of sine squared theta over 2 minus cos squared theta over 2. This looks familiar, okay? it looks a lot like the cos 2a identity, okay? So the one that says cos squared a minus sine squared a, because you see that they're using the exact same angle. And great, if this is cos 2a and it can somehow get to cos 2a, then that is very good, because you see that theta over 2, if this is half the angle, if it represents a, okay, then 2a would be double of it. And if you multiply this by 2, denominator and numerator cancels, you're left with theta, okay? So we'll be able to actually find this. So here's the thing. The problem with this is that it's not in this order, and that is fine. What we could do is just notice that this cos squared theta over 2, it's negative, while our cos squared a is positive. And this sine squared theta over 2 is positive. Sine squared a is negative. Okay, so all that happened here is there's a common factor of -1, and we just need to take it out. If you take -1 out as a common factor from this expression, and then let's just rewrite the cos squared first. So if you say this divided by that -1, they become positive, and now it's positive cos squared theta over 2, okay? And then we're also going to say this divided by that -1, and now it's negative sine squared theta over 2. Great. And now do you see that it looks a lot like that one? So using this, we know now that we still have that negative outside. Since we know cos squared a minus sine squared a is equal to cos 2a, then this is actually negative cos 2 and then our angle. So theta over 2. Okay. And we're just going to simplify that. So this is negative cos, and we see that when they multiply, they just become theta. So what is negative cos theta? We already got cos theta as -3 over 5. So this is simply equal to negative times -3 over 5, which is positive 3 over 5. And that is our answer. Moving on to the next question. Question 5.3 says, determine the general solution of this equation. Okay, here's something you need to spot. You see how we have 4 sine x, and then you have 2 cos 2x. There's a pattern here, okay? You know that cos 2x, that's double angles. We're going to have to use a double angle identity for that. But then you have a 4 sine x, okay? So if you use something that has cos squared, that's not going to work, because then where's this sine x going to fit in? When you see things like this, okay, you have something sine x and you have cos 2x. This is pointing at a trinomial. So this is going to become a trinomial if you ensure that you change this to a double angle expansion that only has sine squared x. Okay, so I'm referring to this one. You see how cos 2x is equal to 1 minus 2 sine squared x, not the one with cos squared x minus sine squared x, because then you're going to have a cos squared x and you're going to have to sort that out. So you need to make sure that they only include sine x, okay? It can be sine x and you also have sine squared x, that's still fine. But like that, it's going to become a trinomial. So that's what I'm going to do. I'm going to go ahead and just change that. So we have 4 sine x, and this is plus 2, but I'm going to change this to 1 minus 2 sine squared x. And so we have is equal to 2, but I'm just going to transpose. Well, it's fine, leave it here because I can see this is going to become negative. So I'll just pull everything over to the right-hand side. Okay, so this is equal to, we have 4 sine x, and then when we distribute here, we have plus 2, and then minus 4 sine squared x. And yeah, I see there's going to be a common factor. So taking this 2 over will be fine in this case. Okay, we should have taken it over already, but it's fine. And so we have negative 4 sine squared x. And then we have plus 4 sine x. And then the 2 minus 2 just give us 0. So this is equal to 0. Great. Okay, and now you see that we have a common factor of negative 4 sine x in both terms. So this is going to be, if you take this first term and you divide it by that common factor, you see that you're just left with sine x. If you take this term divided by the common factor, you're left with negative 1, okay, because it's just the same thing. And now we have two values multiplying that give us 0. So it's either that the first negative 4 sine x is equal to 0, or the second sine x minus 1 is equal to 0. And these are the equations which we need to find the general solutions for. Okay, so if we divide both hand sides here by -4, you see that sine x is simply equal to 0. Here, if you transpose that 1, sine x is equal to +1. Okay, very simple ones. Sine x equals 0, sine x equals 1. You can choose to use the cast diagram. You can use your graph, your actual graph, to solve for this. And that's what I'm going to do. I'm going to use the actual sine graph, seeing that they're both sine. Okay, so let's look at where sine x is equal to 0. Okay, and let's find that reference angle. The sine graph looks like this. Okay, it goes like this and then goes back up like that. So the highest it reaches is 1. The lowest is -1. And we're trying to find out where the graph of sine x has a y value of 0. Okay, so where does it have a y value of 0? Well, this is from 0 degrees to 360 degrees, okay? And where it has a y value of 0 is here at 0. It's also here. So it's at 0 degrees. It's also at 180 degrees. Now, I'm not going to include 360 degrees because what 360 degrees represents is the repeat of 0 degrees. The sine graph repeats itself every 360 degrees. So it means that 360 degrees later, you're going to have another sine graph with this exact pattern continuing over here. Okay, and that's where this y value of 0 comes in again. So it's just repeating again. It's a repeat of this. It's saying it's going to hit the x-axis at 0 again. Okay, so it's just a repeat of these ones. That is a repeat. 360 degrees later, it hits 0. And then this 180 degrees, 360 degrees later, it hits 0 here. Okay, so that's why I'm not going to include that. And so I know that here, my reference angle was simply 0 degrees. And so to solve for x, I'm just saying x is equal to 0 degrees plus, now the sine graph is going to repeat itself every 360 degrees. It's the general solution we're finding. So we need to find the solutions that work throughout the sine graph, okay? Not within specific intervals. Okay, so 0 degrees plus k 360 degrees, or the second solution we saw here was at 180 degrees. So we'll say x is equal to 180 degrees plus k 360 degrees. And I'll go ahead and tell them this is where k is an element of integer values. Okay. And then the next one we're solving for is this part. Let me move this over. Okay, I also meant reference angle specifically. Okay, and then let's look at where the sine graph is equal to 1. I'm just going to take the sine graph again. And let's see where is it equal to 1. Okay, so looking at the sine graph again, where is the graph of sine x, y equals sine x? Where is it equal to 1? Okay, remember that this is a sine graph. It reaches a highest of 1. So this is where it is equal to 1. This is where it has a y value of 1. But which x value is this? This will specifically be at 90 degrees. So that's the reference angle we're looking at. We can go ahead and tell them that our reference angle is 90 degrees. Okay, and let's answer now. So it means that x is equal to, now do you see that it doesn't repeat that 90 degrees, it doesn't repeat anywhere else. Okay, because unlike these other points that are lower than 1, this will only happen within the interval of 0 to 360 degrees. It only happens once. Okay, something like a half, for example. We know that shift sign of a half is equal to 30 degrees. Like, where is the y value equal to a half? Do you see that within the interval of 0 to 360 degrees, this happens twice. One at 30 degrees, the other at 180 degrees minus 30 degrees. That's why on your cast diagram, you say things like that. 180 degrees minus theta minus your reference angle to find the second solution. Of course, if sine was positive, okay? It is very important that you learn how your graphs work. If you can master the trig graphs, which are very simple graphs, okay? Sine of x, cos of x, tan of x. If you understand those, it makes you better at these questions in trig and also the graph questions, which of course come in June and prelims and finals. Okay, so we know that that reference angle is 90 degrees. And now we can finally tell them that x is simply equal to 90 degrees plus k of, how long does it take the sine graph to repeat? 360 degrees. And we know that we don't have to look for a second solution. This only happens once within the interval of 0 to 360 degrees. So we can just tell them where k is an element of integers. And that would be our answer. You can leave the sine graph down if you want, if you just wanted to show that this is how I found it. Okay, so that means we have these three solutions. Okay, so those are our three solutions. And moving on to the next question. Question 5.4 says, prove the following identity. Okay, so we've got a left-hand side and a right-hand side, and we can see that we can actually take the left-hand side further. Okay, so you see that in the numerator, we have sine 2x, which we know can only change to 2 sine x cos x. Okay, so you can see that there's a common factor of cos x. And now we have 1 minus. Now, what should we change this to so that we can also find a common factor? So this is cos 2x. But remember, it has a minus in front of it. There's a 1 here. This will be a distraction. You see how this was able to change into two terms that didn't include 1 or anything like that. Okay, it's just two terms, not three terms. Here we have three terms, but we can use this to get rid of this 1. This would be the problem. So use it to get rid of the 1, and then it's going to change to something. Let it change to something that includes sine x, so it will have a common factor with this. That means we can only change it to 1 minus 2 sine squared x. Okay, so you see how that will multiply in and giving you a negative 1, so it cancels with that positive 1. So minus sine x. And now we have in the numerator cos x out as a common factor. And what is left in the first term divided, you only have 2 sine x. And what is left in the second term, if you divide, you have negative 1. And this goes all over. And when we distribute in, we have 1 minus 1 and then plus 2 sine squared x minus sine x. And then these two just become 0. Okay, so they just become 0. They are gone. So this is equal to, the numerator stays the same. And the denominator, because those are gone, we can take out a common factor of sine x. And then what is left in the first term? The first term will have 2 sine x. The second term will have negative 1. Great. Okay, so these two cancel. They're gone. And now we just have cos x over sine x. Okay, and you see that it's supposed to be equal to 1 over tan x. That is true. So just remember that if tan x is equal to sine x over cos x, then 1 over tan x, which is actually our answer, I'm just trying to show you something, with this is equal to 1 over sine x over cos x. If you divide these two, you will see that you're just going to get, it's just the reciprocal. Okay, you're just going to say 1 divided by sine x over cos x. And if you use tip and times, tip this, swap the numerator and denominator. So now cos x over sine x, and then you change the division to a multiplication. Do you see that 1 times this will stay cos x over sine x? So if you have cos x over sine x, not sine x over cos x, that is equal to 1 over tan x. And so we can see that this is just the reciprocal, okay? It's equal to 1 over tan x. And that is indeed our right-hand side. And so we have solved for this identity. And that is it for question 5. Okay, so that is it for this paper. That is the last question, and it is a total of 100 marks. If you guys have any questions, feel free to leave a comment in the comment section below. And I hope you guys enjoyed this video, and I will see you guys in the future videos.